Hello everyone, welcome to this video. In this video we are going to be performing some psychometric analysis on JASP. So if you don't know JASP, JASP is freeware that is able to do a lot of interesting psychological procedures, including psychometric procedures, with an emphasis on Bayesian analysis, I would say. So we're going to use one of the example files that are included in JASP. So we're going to click on File, and then in the Data Library, we are going to go down and select the SEM folder for structural equation modeling. And we're going to use this dataset, a dataset included in R with indicators of industrialization in 1960 and political democracy in 1960 and 1965. And we're going to select the second one. The first one includes descriptions of the data and already performed analysis, but we're going to actually only get the data, so we're going to select the second one here. I'm going to double click there. So here's a little bit the explanation that I just did a little bit of a screenshot of it, of the different variables that we have here. And we are going to focus on variables y1 to y4, which are indicators of political democracy in 1960. So we can think of these as different items for a measure of political democracy. So one of the things we can do is we can check the internal consistency of these different items. And so the way we would do that is clicking on Descriptives, Reliability Analysis, and then we will select only the variables that we're interested in. So that's y1 through y4. And then I will include them on the box on the right. And so by default we have McDonald's omega, which is a measure of unidimensionality. Yeah, but of course you can also have the very popular Cronbach's alpha over there. You can also use standardized Cronbach's alpha. So it's alpha based on standardized variables first. And then there are of course other measures that you may be interested in, such as the mean standard deviation, average inter-item correlation, etc., etc. Another useful thing you can get is notably the different statistics if we dropped one of the items. So let's have a look, for example, at the Cronbach's alpha. If we dropped some of the items. So here, Cronbach's alpha is 0.859. And so we see that all of the alpha, if item dropped, are lower than that. So it means that if we delete any of these items, we would reduce Cronbach's alpha. So it means that here we should keep all of the items. And of course, this procedure could also be used with McDonald's omega and other indices of reliability.